Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 307. It's a medium level problem. The problem name is amount of time for binary tree to be infected. So you are given the root of a binary tree with unique values and an integer start. Now at time equals to 0, an infection starts from the node with value start. Right? Each minute a node becomes infected if the node is currently uninfected or the node is adjacent to an infected node. So return the number of minutes needed to for the entire tree to be infected. So yeah, this is the example. We have a tree given. The infection starts at time equals to 0 from node number 3. Now at time equals to 1 or minute equals to 1, the infection moves to adjacent nodes. So the adjacent nodes to 3 are 1, 10 and 6. So 1, 10, 6 and 3 all are infected at minute equals to 1. We move to minute equals to 2. The infection moves from node 1 to 5. At the next timestamp, the infection moves from 5 to 4. Now again at the next timestamp, it moves from 4 to 9 and 2. Right? So this is what the problem says. So we need to tell that how many minutes will it take for the entire tree to be infected. If I talk about the second example, so we just have one node and the infection starts from that node and we return 0 because at minute equals to 0 itself the infection starts, right? Nothing fancy in this problem, a traditional breadth first search problem. What I have done is, for simplicity, I'll just show you. So suppose we have a tree. Again I tend to make arrow every time. Just a second. Yeah, so suppose I have a tree. I have value 1, I have value 2, I have value 3. So suppose this is a tree, right? So I was lazy enough to do some stuff. So what I did, I converted this tree into a graph. Now what will happen? So in a graph, I have made an adjacency list. So it will be 1 will have a list having 2 and 3, right? Because 1 is connected to 2 and 3. 2 will have an adjacency list having just 1. 3 will have an adjacency list having 1 and 4. And 4 will have an adjacency list having 3, right? I have done this, and what I have done, I have written a code for a very trivial breadth first search, and then we are good to go. I'll show you that. Now how I have converted this to this. So what I have done, again, just a second, simply traverse the binary tree, and every time you pass the current value in the next iteration, so it will become previous. Let me directly show you that into the code. So if I talk about the function starting at line number 19, so you can see there, we have the traverse function, and the current value on line number 23 is root.val. Okay, now if previous is not equal to null, that means from the previous iteration, if I have got a value, then it is my ancestor, right? Now what I do, if A is connected to B, so I add A in the adjacency list of B and B in the adjacency list of A. So I've done exactly the same thing. I have fetched the adjacency list of the previous node on line number 25. I have added the current value in the adjacency list and I have updated my graph. Similarly, on line number 29, I have fetched the adjacency list of current node. I have added previous and I have updated my graph, right? This is the basic stuff that I have done, and I have done that only in case previous is not equal to null. In the first iteration, previous will be equal to null. That means when you pass the root node in the traverse function, right? And then finally on line number 34 and 35, I have passed the traverse function where current value will become previous for the next iteration, right? When you call the child nodes. So yeah, this will return me the graph. Now if I come to the main function on line number 39, I have called the traverse function. On line number 40, so I have also taken a visited set, which contains the nodes that have been visited, just for simplicity. And then I have also taken a queue, because in BFS you need a queue. I have added the start node in the queue and I have answer equals to 0. So I am running a loop till queue.size is greater than 0, right? And yeah, just fetch the current node on line number 48, fetch the adjacency list of the current node, and then traverse the adjacency list of the current node, right? Now if the current neighbor in the adjacency list you have started traversing, now the current node is already present in the visited array. That means that has already been processed. Just skip it on line number 52, else add it to the queue and add it to the visited array, and we are good to go. finally, when everything the loop breaks or the loop is finished, we return answer -1. Why do we return answer -1? Because at minute equals to 0 itself, the infection starts. But even if we have a single node, we are coming inside the loop and we are incrementing the answer on line number 45. So even in case of a single node, you get answer equals to 1, but we need to return 0 because it starts from 0th timestamp, right? So that is why we have written answer -1. And yeah, the solution is accepted. Hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. Also, if you have any queries, do mention that into the comments. I am recording this video for the second time. The first time I recorded all the videos, there was no audio, so yeah, it is taking time for me. Otherwise the videos would have been uploaded. Okay, take care. Bye bye.